Hello, welcome to Free Prep Hour. If you were expecting my colleague Rena, she could not make it tonight. She had some things come up, so I am here subbing. My name is Kat. I used to do these before Rena did. And now I don't, but I'm back for tonight. So good to have you all here and welcome. Oh my God, we have so many people. Yikes. Rena's so popular. I never got this many people. This is great. Oh, more people coming in. So, especially because there's so many people, we're going to be communicating a lot in the chat tonight. So I'll go say hello. I'll say hello in the chat. Hello. And then what I would like all y'all to do is say hello to, and maybe tell us where are you and where are you at in your GRE journey. I am in Brooklyn. I have been teaching the GRE for 6 years. So that's where I'm at in my GRE journey. Staying in the GRE a lot. Nice. Berkeley. Oh, I'm going to go out to Berkeley end of July. My best friend lives out there. That's awesome. Beautiful. LA. Nice. Ooh, a lot of LA and Orlando. Cool. Newport Beach. Awesome. All over. Yay. This is like, I know it's been a rough year being online, being in Zoom, but the beauty is, oh yeah, we got someone else from Brooklyn. Cool, Sri Lanka, awesome. I'd love to visit Sri Lanka someday. Heard it is amazing. Michigan, Pittsburgh, awesome. Ooh, so lots of folks taking it soon. Some people just starting. Awesome. Ooh, Guyana, cool. Yeah, this is the fun about being online. We're all over and then we're all here together. So cool. Yes, so because we have so many people, we don't do cameras and mics in these. Also because we record them and post them on YouTube. And, if you're visible or audible, then it makes the sort of posting difficult because we have to get permissions and stuff. A bunch of New York folks. But please, I don't want to, it'll be like a little bit of me talking at you because of the format, but I don't want it to be like just all about me talking at you. So do chat, do ask questions. I'm going to try to hold a few minutes at the end to do some kind of open Q&A. But let me go ahead and tell you about what we are going to do tonight. Hawaii, nice. I, at one point in my life, came very close to moving to Hawaii, and that's like my my one that got away story is like I almost moved to Honolulu. But it's good. Hawaii doesn't need me moving there. Hawaii is all good. It's good to go visit. And let Hawaii be Hawaii. Yay, Kerala. Awesome. All right. So if you've never been to a free prep hour before, we do these twice a month. My colleague Rena does one. My colleague Whit does the other. I used to do them. We also post these on YouTube. So if you're just starting out, go to our YouTube channel, check it out. All these free prep hours in the past are posted. Amazing, comprehensive, free resource. Lots of like everything, all topics, lots of stuff covered in these. So the way it works is it's an hour. Instructor picks a topic, teaches for an hour on that topic. So it's a little bit luck of the draw. What are you going to get? Today we're going to do quant, and the problems that we do today are going to be drawn from this book. This is actually an older edition of this book, but this book, it is more than 5 pounds, tons and tons and tons of practice problems. So if you are also just starting out, I always say the 2 books I think you should get, if you're only going to get 2 books, the official guide, you got to get that, made by ETS, the people who make the test. This is a great second book because it's pretty much, you're not going to run out. If you do every problem in this book and you're not where you want to be, probably haven't been doing the problems, reviewing the problems thoroughly enough. But if you're reviewing well, this is all you need. So we're going to talk about ratios because ratios are a topic that I think give people a lot of grief. Like I see a lot of my students in classes, we get kind of deep into the course and then we're still having trouble with ratios. Yeah, Anna Maria, you are not alone. That's why we're doing them, because people struggle with them. So my hope is I can give you a few simple, clear tips about ratios that will make them feel more comfortable. A couple techniques that I find helpful in solving ratio problems. And we're just going to start. We're going to start on the ground floor. We're going to build our way up. Probably this is geared a bit, at least to first, probably a bit more to people starting out, but my hope is that there will be useful tips and tricks for everyone at every stage along the way. And if you're like, I'm amazing at ratios, I don't need this, go to YouTube and find a different one and watch that one. That's cool. I'm good with that. Like I said, it's a bit luck of the draw. So let's talk about what is a ratio. Here's a little problem to begin. What is the ratio of jelly beans to peanut butter cups in this bag? Chat me. Yeah, so this is fun. I've gotten 2 different answers. I've gotten, we have Arena here tonight. I was like, that's like my colleague, Rena, who's supposed to be teaching tonight. Some people are saying 12 to 9, and some people are saying 4 to 3. And this is what is cool, is these are actually just exactly the same thing. It's like a fraction. Ratios are very similar to fractions. If I see 2/4, I know that's the same as 1/2. 1/2 is just my reduced version. So it's the version where I can't divide it down or simplify it anymore. With ratios, it's usually the most reduced version that we are given when we're working with a ratio in a ratio problem. So a ratio is always going to describe the relationship between 2 things. And it's always going to be the most reduced form of that relationship. So, key facts about ratios. In ratio problems, and we'll kind of build on this more and more tonight, it's really important to keep track of what is an actual number. Like there are actually 12 jelly beans and actually 9 peanut butter cups. And what is just a ratio? There's a ratio of 4 to 3. The ratio just tells me about relationships. So when I get a ratio, I often don't actually know things about the actual number involved. I just know things about the relationships between the parts. Let's continue with that, because that's, I think, the tricky part about ratios is like actual numbers versus the ratio, which is sort of our ideal relationship, our core relationship. So what about this? Here's another one for you to chat me. I have a ratio of licorice to chocolate, 3 to 4. What are the possible number of total pieces? How many total pieces might be in the bag? And the important word here is might. We can't say for sure exactly how many pieces. What are some possible numbers? Yeah, and we're looking for possible numbers of the total. The total. Cool. This is looking good. Awesome. Yeah, all right. I like it. So I will accept any multiple of 7 as the total number. And here's why. It's saying, okay, I have licorice, I have chocolate, and then I'm going to have a total. So sometimes with ratios, I like to kind of set them up like this. Like I have my 2 parts, and then I use a little double colon like this to indicate the total. And what this ratio is saying is for every 3 pieces of licorice, like every time I put 3 pieces of licorice in the bag, there have to be 4 pieces of chocolate. So the smallest possible total number I could have would be 7, because every 3 pieces of chocolate have to be 4 pieces of licorice. So, and I can only add chocolate in groups of 3s, right? So I could have 2 groups of 3, in which case I'd have 6, which means I'd then have to have 2 groups of 4, which means I'd have 8, which means I'd have 14 total. I could have 3 groups of 3 and 3 groups of 4, and then I'd have 21 total. Now, here's something that I find super, super helpful in terms of notating ratios. I like to do this with my ratio, just to remind myself that I am not concerned with, this is not telling me I have exactly 3, exactly 4, exactly 7. It's saying I have X groups of 3, the same number of groups of 4, and the same number of groups of 7. So my total will always be groups of 7. Chocolate will be multiples of 4. Licorice will be multiples of 3. And so when I see a problem like this is actually how I might start. Like, okay, I have a ratio of 3 to 4, and then I often like to add in the total because that can often be helpful. And this notation helps me stay really clear about what is a ratio, what is an actual number. And that's something the GRE likes to play a lot of tricks around. Really something important to keep track of. Okay, if I don't have any actual numbers, I don't know. I know it has to be a multiple of 7, but I don't know exactly how many. What if I now said, all right, I have 16 pieces of chocolate. How many pieces total are in the bag? Try that out. If I have 16 pieces of chocolate, how many pieces total, chocolate and licorice, are in the bag? Total. I'm gonna be really like pedantic about the question because that's actually super important for the GRE, being really pedantic about answering the right question. Because you can do all the nice math, but if you answer the wrong version of the question, you don't get the point. That's a huge bummer. Common small error, huge bummer. Nice, this is looking good, yeah. So one way that you can think about this is to say, like, all right, if there's 16 pieces of chocolate, what is X? Well, 4X equals 16. Means X equals 4. So that means everything in my ratio has to be multiplied by 4 to get the actual number. So I'd have 12 pieces of licorice. So that's not what we're asking here. We're asking for the total. Total is going to be 7 times 4, 28. So by including this X, I might say called the unknown multiplier, you don't have to remember that name. By including this X, it helps me translate back and forth between the ratio and the actual numbers that are involved in something. And that's super helpful, super important. All right, let's get into some problems now. We've looked a little bit at some foundations of ratios. We've seen 3 important things. They relate parts to parts. They're usually expressed in the most reduced form. And if you don't have any actual numbers, you don't know anything about actual amounts. You just know things about the relationships. Here's a full GRE-like problem. Oh, yeah, sorry, I got a question on this one. Why isn't it 3x equals 16? Oh, because I told you the number of chocolate was 16, and the chocolate is the 4. So that's why I say 4x equals 16, because the licorice is 3, chocolate is 4. That's also something to be super careful about with ratios is the order. You know, it goes licorice first, then chocolate. Really, really easy when you're under pressure going fast to flip ratios around. So I try to be extra, extra careful. Yes, yep. That's a really nice way to put it. Is it a rule? Your total number will always be a multiple of sort of item 1 plus item 2 in the ratio. Or if you have 3 things, you know, we might have a ratio of this to this to that, then you'd sum up those 3 things. That is definitely a rule. Nice way to sum it up. Cool. Sorry, I should have paused to give more time for questions because those are excellent questions, but definitely put questions in the chat, stop me. We can go back, like ask your questions. I want to answer them. I want to get everyone feeling good about everything they do. Okay, now here's a problem for you to try. Chat me the letter when you have it. Ooh, all right. So I like what I'm seeing. We're seeing, actually, it's kind of interesting. I'll get into what's interesting in a moment. Everyone's picking one of two answers, either B or C. And one of these two is the correct answer. One of them is a trap. What is the trap in this problem? How is the GRE trying to mess with us? Yeah. Yep, the order. This is so mean. This is so mean, but this is also very GRE-like. 20 birds and 6 dogs. But that's not what the question is asking us. It's asking us from dogs to birds. It flips it around. So C is my trap, because C is birds to dogs. But that's not what I want. What I want in this problem is dogs to birds. So always, 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 not just for ratios, actually, this is for everything. Start by writing down what your goal is. What are you ultimately solving for? Even and especially if you look at a problem and you think, yeah, this is so easy. Why are we being made to do this? There are easy problems on this test. And you do not want to miss them because you made a little error. So if I see a problem and my first thought is, I got this, is slow down. I'm write down more. I'm even more like precise and orderly and careful, because if I know I can do it, I want to make sure that I do it right and get it right. And this, like we just talked about, big trap with ratios is this order. So B is my correct answer here, 3 to 10, because that's where I say, okay, I have 6 dogs and I have 20 birds. And then I see that these are not the most reduced because they're both divisible by 2. So I divide both by 2 and I get 3 to 10. Notice also what we just did is a great thing to do as you study. So as you review problems, think about, how could someone get this wrong? How is this problem trying to trick someone? Why is this answer there? Why is there 3 to 10 and 10 to 3? Super, super, super good to do, because if you can start identifying these traps as you study, you're not going to fall into them when you take your official test. And for those of you who are taking the test real soon, like this weekend or next week, this kind of stuff is great to focus on, like eliminating small errors, building more error-free habits. Like this is actually a great way to get a couple extra points in your last few days, last week of studying, is ironing out these little mistakes. It's not easy to fix, it takes work, but it's one of the things I think that you can fix faster than some other issues. Yes, yep, great question. Do you have to divide both numbers by the same number? 100% you do. It is exactly the same as if I was going to reduce a fraction. So if I was going to reduce a fraction, I'd say, whatever I do to my numerator, I gotta do to my denominator. Otherwise, I'm going to change the fractions amount. But if I do the same thing to both, I'm good. Same with ratio. Whatever you do to one part of the ratio, you got to do to the other part. Great strategic question. Is it better to guess on an answer rather than leaving it blank? Yes, always, 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 always. And that's something you can practice tonight. When we do a question, even if you aren't sure and I call time, give me an answer. You do not lose points for wrong answers. You only gain points for right answers. So you can only gain by guessing. You might guess right. Can't lose. Really important strategic thing. Yep, good question. All right, let's try another one. This one is, just to point out, this one asks us to select 2, and I'll put little letters next to these boxes. But anytime you see these square boxes, it means you can select more than one. This one says specifically to select 2. Cool. All right. So things are getting a little more complicated. There's more going on. We're going to start ratcheting up the difficulty. So I want to give you a suggestion in a problem like this. When we start to get into more complicated situations like this, something that I find enormously helpful is make a table. So I love tables for all kinds of things, rates, ratios, some complicated word problems. Organize that information. So I might start by making a table. I've got tomato paste, beans, and soup. And then I can start filling in my table. So I'd say like, all right, I have X cans of beans, twice as many cans of soup, so 2X cans of soup, and then half as many cans of tomato paste, so 1/2. Now, I have variables here, but variables, I don't know, they're very abstract. What could I do if I didn't want to work with variables? What's an approach that I can use if I want to avoid a lot of algebra variable math? Yeah, I can pick numbers. Anytime you just have relationships and no actual amounts, pick numbers. Fractions, percents, ratios, some problems that have like a single constant variable. This is a great approach. So I'll look at my graph, and the smallest thing I have here is tomato paste. So I'm going to start with the smallest thing. What is the minimum number of cans of tomato paste that I could have in this cabinet? Yeah, I got to have 1. I can't have half a can. So this is something else the GRE likes, is sort of hidden integer constraints. Hidden, where it'll say, all right, I can't have, half a can of something, half a car, half a house, half a person, half an animal. If it's disturbingly expensive to cut something up, can't have parts of it. So I have to have at minimum 1 can of tomato paste, which means twice as many beans, 1/2 to 1. So 2 cans of beans, which means 4 cans of soup. So this is my minimum scenario, which means my minimum number is 7. So right off the bat, cool. Answer B has to be right. Definitely could have 7 cans. However, this is just my minimum number of cans. What can I then sort of extrapolate about total possible number of cans? If my minimum possible number is 7, kind of a ratio of 1 to 2 to 4 to 7, what has to be generally true about the total? Yeah, yep. Same idea as before, must be a multiple of 7. So my minimum is this. I could also say my ratio here is something like this, like 1y to 2y. I'm using y instead of x so as not to confuse with the x given in the problem, but a multiple of 1, a multiple of 2, a multiple of 4, which means my total is a multiple of 7. And I only have one other multiple of 7 here, which is 63. So picking numbers, making a table, watching for hidden integer constraints, all some good things coming up in this problem. Great question. Yes, if it asks for you to pick 2, you must pick 2 and get them both correct. You don't get any partial credit. That's true on all of the multiple select problems, quant and verbal. You must get all of the answers correct. I got another question. Do you ever simplify this? I am not 100% sure what that's in reference to because I saw it a couple minutes after you asked it. So if you want to add kind of more detail to that in the chat or elsewhere, I'm very happy to answer. Ooh, yeah. So I got a great question. If x equals 7 and I plug that in for the number of tomato paste, if I plug that in for the number of beans, it doesn't work, because then I get 3.5 cans. And the answer to this is This is not possible. The number of cans of beans, X, cannot be 7. X must be a multiple of 2. That's what the ratio tells us. Maybe the confusion is this. The problem is not asking us to solve for X. It's asking us to solve for the total number of cans in the pantry. So the total, yeah, the total is a multiple of 7. Yep. This is one of our big themes tonight because this has come up a bunch and a bunch of questions for a bunch of people. Be really precise about what you are being asked for, because this is one of those pitfalls that I think is going to get all of us at least once. So, you know, if you only take one thing away from tonight, actually make it this. Read the question, write down what you're solving for, write it down. Always, every question, even if you think it's easy, do it. I promise you it's going to make your life better, easier in regards to the GRE. Yeah, this is so, because this is about ratios, I would not kind of try to work this out algebraically. I would definitely, like, you know, even though there's variables involved, I would think about this more as like a ratios, picking numbers problem. Definitely not going to get into like setting up, kind of doing algebraic operations with something like this. And that's something I think to just keep tracking as you study, like, what is the topic of this problem? What is it really about? Oh, this is really about ratios because it's relating these different quantities. It's not so much about setting up equations. There are some problems that could be done kind of with algebra or with kind of ratio logic. This one much better, I think, is a ratio. Yes, you can use scrap paper. If you are taking the GRE in person, you are given unlined white paper at the test center. If you are taking the GRE at home, you are required to use an erasable surface, like a piece of laminated paper or a small whiteboard. So 2 different options, both can be really good. Whatever option you're going to choose, practice with that material going into the test. Yeah, so here, this is why I would not do this algebraically. Let me think about this. Let's see, 3.5x equals, yeah, so if you set this up 3.5x equals 63, then x equals the number of beans. So I'll be saying there's 18 beans, which means there's 9 cans of tomato paste and 36 cans of soup. So, you know, if you're not certain with an equation, go back to your setup. Like, what does x represent in this chart? I got another question. Are you given the option to take the exam on paper? Pretty much never. In theory, there is a paper exam. I have never, neither I nor any of my colleagues in decades has ever had a student take a paper exam. I think it is only in geographic locations that don't have a computer-based testing service, which I think is very, very few places, if any, at this point. All right, so we're gonna do a slightly, when I picked one, ooh, great question. When I picked 1, I was not making x equal 1. I was making the cans of tomato paste equal 1. And the reason for that is the smallest quantity here is tomato paste. And I wanted to think about the minimum number, because the minimum number is like the most reduced form of the ratio. And that's always what we want with ratios. We want the most reduced form. So I made the cans of tomato paste equal to 1 because that's the smallest actual number that I could have for tomato paste. I can't have half, I can't. So then if 1/2 x equals 1, then I know that x equals 2. So I was picking actually for that. And that's a good rule of thumb, you know, with a ratio. Start with the thing that has the smallest amount and then minimize that. Great questions. All right. I want to do a slightly different situation. Now we're going to look at a different format, quantitative comparison. So if you're like an old hand at the GRE, you know QC, you know how these work, just dive in. If you are new, I just want to say something before you dive into this. in this problem, in problems that look like this, you are always answering the same question. Which, how do the quantities compare? And you are always given these four options. A is greater, B is greater, they are equal, or you cannot tell. And if you are going to pick D, one way to think about D is just, it's not always the same. Sometimes one way, sometimes another. So if I pick A, B, or C, I want to feel really confident that this relationship is always going to be true, no matter what. But if I pick D, this is what I'm going for. Cool. All right. Seeing lots of good stuff. Let's talk about it. So when I have a problem like this, when I have a quantitative comparison problem, I like to try to, always I really want to be certain before I pick A, B, or C, is this always going to be true? So I really want to try hard to think through possible options. What are my possible options? Can I get there to be more than one possible option? That's kind of always what I'm trying to do. So I might look at something like this and say like, okay, I have 11 dogs. I have 13 cats. This is my ratio. So if I add new animals, add 2 new dogs, I get 13 dogs and 16 cats. Awesome. So I have found an example where my two quantities are equal. But I do not want to stop there because the GRE is tricky, and especially comparison problems are tricky. There's almost always a twist or a trick. So I might do what I just did and be like, that feels very straightforward. That feels too straightforward for this test. This is a possible number, right? I could have 11 dogs and 13 cats. Do I have to have 11 dogs and 13 cats? Is this the only possible number of animals I could start with? What's another possible number of dogs and number of cats? Yeah, I could have more. I could have double, right? So I could have 22 dogs where I have 2 groups of 11. And if I have 22 dogs, I also need to have 2 groups of 13 cats. So I could have 26 cats. And in this case, if I add 3, but look what happens when I add. So yes, 22 to 26 and 11 to 13. These are the same ratio, though they are different amounts. But look what happens when I add. Now I have 24 to 29. And this is not the same as 13 to 16. This is a different fraction. So 22 to 26 is the same ratio as 11 to 13, but it is a different actual number. And so when I combine these new numbers with my 2 and my 3, I end up in a different place that is not equal to 13 over 16. So in this case, my answer is D. Yep, the question is asking about ratios. I have 2 good questions. So I'm going to answer one, then I'm going to answer the next. The question is asking me about ratios, for sure. 24 to 29, not the same ratio as 13 to 16. Yeah, yep. This is important. This is important. I'm glad people are asking questions. I'm glad that we're dwelling on this because this is the big trap with ratios. This is the big trap. This is why we're doing this problem. Yeah. Yep. Oh yeah. Yeah. 29 is prime. 29 is a weird prime. You always think it's not prime, but it is prime. I totally get that. But this is just a big reminder. 11 to 13, that's not an actual number. It's a multiple of 11 and a multiple of 13. That's the actual number. Yeah, so I got the 22 and 26 by saying, okay, for every group of 11 dogs, I have to have a group of 13 cats. So what if I had, double that, right? Like what if I had 2 groups of 11 in dogs? Then I'd have 22 dogs. Then I need to have 2 groups of 13 in cats and 26. So the ratio is basically saying, all right, every time we get 11 dogs in the room, we have to bring in 13 cats. So if we bring in 2 groups of 11 dogs, then we have to bring in 2 groups of 13 cats. If we bring in 3 groups of 11 dogs, then we have to bring in 3 groups of 13 cats. So any multiple of 11, same multiple of 13, possible numbers. So for example, I could also have 33 and 39. And then I would again end up with a different ratio when I add in the 2 and the 3. So be very careful if a problem is combining a ratio with actual numbers. I hope that answers. I got a good question a moment ago that I want to answer, and then I'll check in with some of the current questions. I got a great question. How did I know to keep going? That is an excellent question. Super important. And my answer is because it is quantitative comparison. Quantitative comparison, I'm going to abbreviate that QC, almost always has a trick. If it seems straightforward, keep going. And really try hard to prove D. So I'm not going to settle for A, B, and C unless I've sort of thought of multiple scenarios and I keep getting A, B, or C. I have another way of proving it has to always be equal, or one always has to be greater. So I really, with QC, I'm very rarely satisfied to just think of one example. If it seems straightforward, I'm also very distrustful of that. That's how I know to keep going, because I just kind of know the tricks of the test. And that's a big goal in your studying. You're not going to know these things starting out. They're going to feel weird. It's going to take some time. But as you study, keep trying to look for these tricks, these twists. Try to think about getting inside the mindset of the test. D is sometimes one way, sometimes another. I got a question. It seems like a lot of the QC answers is D. Is this generally true? No, I think ETS tries very hard to avoid patterns. So you will definitely get, some that are D, but you're going to see some that are A, B, and C too. I wouldn't just sort of default to D all the time. That can get you in trouble. Yeah, it's like a fraction. This is a great question. How do I compare the sizes of ratios? Just like you'd compare fractions. And a great way that you can compare fractions is convert them to decimals. So let's say, and to be honest, I'll do this right now. Yeah, I'll go back and show the answer choices. So let's say, for example, I need to compare 24 over 29 to 13 over 16. And I'm not kind of sure which one is which. Like if I have 2 fractions that are kind of close together, what I'll do, and this works for ratios as well as for fractions, is I'll just convert them to decimals. So I've got my calculator. I'm going to do 24 divided by 29. that gives me 0.83. And then I'm going to do 13 divided by 16. That gives me 0.81. So I say, this is greater. Great question. Definitely something that could come up comparing two ratios. Do it like you would with fractions. Convert to decimals. There is a calculator on the test. So it's like a desktop on-screen calculator that's part of the test software. So you have to use that calculator. You can't bring your own. It is a bit clunky, so you don't want to use it too much, but you definitely will want to use it sometimes. It's there and you should use it. Sometimes A can be greater, but not always. So if I'm going to pick A, B, and C, A, B, or C, I want to be certain it's always. And yay, Irina, glad I answered your question. Dina, when to know not to use the calculator. That's something I think you're going to figure out as you study. So as you're doing problems, as you're reviewing, just think about where can you do the calculation quickly on your paper? Where is that going to be slower and accurate and you need to use the calculator? But do also notice, are there times when you are leaning on the calculator and it's slowing you down? Not penalized for using the calculator, except for the fact that it is slow and it's easy to make mistakes with because you often have to click on it with a mouse. There is a square root button on the calculator. You can find square roots. For large exponents, there's a lot of other tricks. So large exponents, you're not going to be using the calculator, but that is like that's a whole other topic that would take us, a long time to get into. So definitely go look on the YouTube channel. There's, I think, a few lessons on exponents on there, and I would check those out, and they'll help with that question because that's a complicated one. Oh man, this is great. You guys are full of great questions. I love it. So it's nice to have a big group. All right. Let's see. Using the calculator does not impact your score. They do not track it. They do not use it when they calculate your score. You could use the calculator on every problem. You could use the calculator on no problems. It is up to you to figure out the calculator strategy that works best for you. It's, I think, Manhattan Prep GRE is the channel. All right. Let's try another problem. Oh, the answer to this problem is D. The answer is D, because we had one situation where they were equal, and we had one situation where A was greater. So the answer to our quantitative comparison problem is D, because sometimes it's one way, sometimes it's another. If I'm going to pick B, it would be like every single example I could think of, quantity B was greater. Try this one. My God, guys, sorry I was clicking around like that. I thought I'd pause the screen, but I didn't. So sorry if you were trying to see the problem and you were like, it is moving. I feel motion sick. Oops. It's been a really hot and humid day here in Brooklyn, and maybe I'm feeling it. Awesome. This is going great. So this is where that idea of the unknown multiplier might be helpful to say, like, all right, I have cars, I have trucks, and I have, for every one car, I have 3 trucks. How many trucks? do I actually have? I have 51 actual checks. So I could say, all right, 3x equals 51. 51 is one of those numbers that looks prime but isn't. Like 29 looks not prime but is. 51 looks, I think, prime but is not. Divide both sides by 3. X equals 17. And since I have 1x for cars, I got to have 17 cars. And that is a good example of using the unknown multiplier. That's our fourth takeaway. This one seemed good. People seem to be having a good time with this one. Questions? Yes, you can do a lot of these with proportions. I personally don't, because I find that not all of them work well with proportions. So I tend to use sort of tables and the unknown multiplier, because to me that approach allows me to do pretty much everything. And so then I have like one consistent system for all ratio problems. And I like that because it's simple to me. Doesn't mean that is the only way that things can be done. Definitely can use proportions for a lot of them. You're just going to want to know like where maybe does proportions not work as well and have an alternate. And I think maybe one of the next ones we look at will be an example of the one where it's not great as a proportion problem. Let's do this one. So the next one we're going to do is not multiple choice. So a lot of the GRE is multiple choice, but not all of it. Some of it you have to type in a number. This is one of those. You can return to questions throughout the test. Yep. If anyone's done the GMAT's very different. Within each section, you can move around. So once you leave a section, that section is gone. But when you're in that section, you can move around between problems. Yeah, this is going good. So we got our plants. This is another great unknown multiplier problem. You know, for a tulip, I have tulip, I have rose, and then maybe I have my total. So I just fill out my little chart. And then I deal with my actual numbers. I have 50 plants total. That means X equals 10. I have 10 groups. So that means I have exactly 10 roses, and then I have 40 tulips. Yeah, this is definitely, I think, you know, as we get into increasingly complicated ratio problems, the proportions start working less well and the tables start working better. So that's why I tend to, you know, in my own practice and in my teaching, I tend to prefer strategies that I think are scalable. And that's something to think about as you study. Like, so there's some approaches that work pretty well for easy medium problems. We're going to break down with hard problems. We see that in verbal, we see that in quant. So thinking too, like, are there places where you notice that you're doing well with the moderate stuff, but having trouble with the hard stuff? Do you need to shift your approach in some way? Lots of folks getting this right. Looking real nice. questions. Cool. All right, let's do, let me see how much time we have. Let's do one that's like a little bit trickier, just to kind of get a little bit more difficulty in, especially for some folks who are cruising along. So it's a little trickier. See how it goes. Awesome. I got a comment I'm screen sharing, which I'm not sure what that meant. I hope I'm screen sharing. I'm tending to be screen sharing. I hope no one's seen anything weird. I don't think I got anything weird on my screen. I think I just got this problem. Yeah. Yikes. I was like, what have I done? But I don't think I did anything on. The group chat. Oh, what do you mean you saw the group chat? Oh, that's weird. That's a glitch, actually. That's not supposed to happen. Oh, man, that's so weird. That's a Zoom glitch. I've never had that happen before. Anyway, thanks, guys. That's good to know, because that should not have happened. Anyway, it was mostly just people like making correct answers. So that's good. You guys are all doing great. Everyone's getting to be as correct. So yay, we can all appreciate that we're mostly right. Cool. Oh, I actually have a question. Can you see the chat box now? So weird. Anyway, who knows? Don't know. Another great unknown multiplier problem. Okay, I have male to female. I'm always going to label, super easy. This is glitchy. This is weird. Anyway, I'm going to close. Nah, I'm not going to close the checks. I want to see what you guys are saying. I have multiple of 3 men, multiple of 4 women. What else do I know? There are 5 more female employees. So I could say like, all right, the number of male employees plus 5 is the number of female employees. And now it does become a bit like algebra, because I can say, the number of male employees is some multiple of 3. And the multiple of number of female employees is some multiple of 4. And then I can solve for x. And now I can find the number of male employees because I know x. So the number of male employees is going to be 3 times 5, 15. And that is our answer. So making a table, unknown multiplier, because I am solving for the number. Oh, why isn't it 4x plus 5? Great question. There are more women. So I need the 4x to be bigger. which means the 5 needs to get added to the men. So this is a common thing that happens in algebra translation. We flip around, we sort of add or subtract to the wrong side. If that's something that you do, ask yourself, which are there more of? Okay, there are more female employees. Does my equation reflect that? Another way that you could think about this is the than. Whatever comes after the than, that's what I'm applying the operation to. 5 more than. So that's men plus 5. So you can use the than to help you. You can sort of think about who is there more of. It's not always that we add the number to the thing that's closest to the number. That's what can be confusing about these translations. Cool. Can do this one by back solving from the answer choices. It's a little slow, I think. That's why I would say, I think back solving from the answers is great if you're, in a pinch on test day. If you see this on the official test, blank on the algebra, yes, just test answers, especially, if you can do the arithmetic cleanly and quickly. Great way to do it. Great backup strategy. Try to learn the other way to do it and get comfortable with that. It's a good skill building thing, good to do. But yes, you can totally do this by working from the answers. Anytime you have numbers in the answers. Yeah. So what I'm doing here is I'm saying, yep, I'm totally I got a couple requests to walk through this again. So I'm gonna walk through it again. So I'm saying all right, the number of men plus 5 equals the number of women. And then I know that the number of men is a multiple of 3x. And the number of women has to be that same multiple of 4. So like if x is 2 here, x is 2 here. So I just replace the number of men with 3x and the number of women with 4x. And I get 3x plus 5 equals 4x. And then I want to solve for x. I want to isolate x. So my cardinal rule of solving equations, whatever I do for one side, I do to the other. So I'm going to subtract 3x from both sides. Cancels out here. 4 minus 3 is 1. So I just get 5 equals x. So that's saying the number of men is 3 times 5. So I have 5 groups of 3. And that makes it work. I hope that I walked through the things that people wanted me to walk through in that explanation. If there is something in there, if I didn't touch on the thing that you were hoping I would, ask another question. Let me know. I don't think we have time. I think we're almost out of time. I know. If you were hoping for super hard stuff, there will be super hard stuff. There is also some super hard stuff on the YouTube channel as well. So I apologize if you were hoping for super hard questions today. I went in a slightly different direction. I think that the Prep Hour Arena is planning next is going to be a super hard geometry lesson. So we're kind of 2 options today, more foundational ratios versus super hard geometry. So I think if you're hoping for super hard quant, there will be some in the future. But for now, we are out of time. So just to wrap up, ratios, parts to parts, usually reduced. If you just have ratios, you don't know anything about actual amounts, be very careful about that. Use the chart, use the unknown multiplier, super helpful. The next one I think is, I don't know, but you will find them on our website under free resources. And they're 2 a month. So I think the next one should be coming up in a couple weeks. They're usually about 2 weeks apart. All right. That is it. No more events, I think, in the next few days. You can, this is something I want to say before we go. You can also go to any of our classes first session for free. So go check out this link. If there is a class starting in the next few days, you could go sit in on it for free. If not, next free prep hour, June 24th. Rosara, thank you. You are the best. That is awesome. And yeah. What is a reasonable amount of study time for someone who has been out of college for 10 years? I usually say average prep time 3 months, though I've seen it done in 2 weeks. I've seen it done in 2 years. Both had successful outcomes. So if you've been out of college for 10 years, That's not super unusual. I have a lot of students who've been out of college 10 plus years. I would say, you know, probably you want a little bit more time just because you're going to have to get back into the habits of studying, which is a great thing to get into anyway if you're going to go to grad school. So that I think is helpful. But thank you, Bianca. That's so sweet. But I would say maybe, you know, a little bit longer, like 4 to 6 months might be ideal. If you don't have 4 to 6 months, it's not the end of the world. You just are maybe going to need to have kind of a more intense number of hours each week. So when I say 4 to 6 months, that's thinking maybe I spend like 5 to 10 hours a week studying. Generally, I'd say like somewhere between 5 to 15 hours a week, depending on how long your overall timeline is. Also depends a lot on what your life is like. You know, do you have 15 hours a week? Maybe you don't. Maybe you have 5 hours a week. You're going to make that work. You can make that work. And what was my other point I wanted to make? I forgot. I've seen lots of different things work for lots of different people. Trying to take it before August. I would definitely, like, if you're just starting fresh today and you want to be done by August, I would say like probably more on the 15 hours a week end of the spectrum. Depends also, of course, where are you starting? Where do you want to go? So take a practice test. It's just for you to get a baseline. You know, you don't have to feel prepared. You don't feel prepared. Just take it. Thank you, Bianca. And that's a helpful link. And then figure out what score you kind of reasonably want to shoot for. You know, look at the median scores for your programs. And that might also give you some perspective on, you know, how much are you looking to do. How can you prepare for writing? Read the writing chapter of the official guide. Read the sample essays. And then write some timed essays. Write some, you know, get a bunch of prompts and spend 5 minutes brainstorming for each. But definitely start by looking at the sample essays the ETS gives to get a sense of what they want from you. And remember, depends on your program, right? If you're applying to an MBA, essays don't matter that much. If you're applying to something in the hard sciences, essays don't matter that much. If you're applying humanities PhD, essays matter more. You can take a free one on our website. It's got essays. It's got an experimental section now. So, you know, it's all complete. It matches the GRE interface. It's free. Our verbal is a little hard. So I find that the quant score is an accurate predictor. The verbal score, usually people go up a little bit on their official test verbal score compared to our practice tests. That's my caveat about our practice tests. But in every other way, I think it's very GRE-like, very good. You do not know which section is the experimental section. That's what makes it hard. You just try to do your best on all of them. I wouldn't put too much thought in trying to guess which one is experimental as you're taking the test. It can be distracting. Cool. All right. My voice is going to go in like 2 seconds. So I'm going to sign out, but thank you guys all for being here, asking awesome questions. Whit and Rena will be back with our usual programming in the future. Good luck to everyone who's taking the test soon. Hope it goes super well and you can never have to think about the GRE again. That is my dream for all of you, is to get to a point in life where you never have to think about the GRE again. And I hope it is soon. Have a good night.